Continuing with section 4.2, and we want to use we want to show another example of closed interval method. So in here it says find the absolute extrema of h of x equal to x to the power 4/5 times x minus 4 to the power 2. This function is continuous where in everywhere, and we're limiting the absolute extremas to a closed interval. So extreme value theorem is satisfied. What is remaining is 1, find the critical numbers and evaluate numbers and evaluate the function at them. 2, evaluate the endpoints. Then 3, compare. Critical numbers. How do I do the critical numbers? Critical numbers is where h prime does not exist or is 0. So I evaluate h prime. H prime of x, it's in here is a product rule, so 4/5 comes down, x to the power 1 less, and then times the second one, and then plus x to the power 4/5 times 2 times x minus 4 to the power 1 less, which is 1, times derivative of inside, which is 1. Now, here, we know that to find the critical numbers, I have to factor the derivative. Now, here, how do I factor the derivative? One way is to write this out as quotient, and then common denominator, and then factor. Another way that we discussed beginning of the semester is this. Let's say we look at each number. Here is 5. This 5 comes to the top, it becomes 5 to the power -1. And so between this term and that term, 5 to the power -1 is the lowest. There's no 5 in here, so 5 to the power 0 over here, and 5 to the power -1, that's the lowest exponent you get for factor 5. For 4 is 2 to the power 2, 2 is 2 to the power 1, so I factor a 2. That's the lowest. In here, between x to the power -1/5 and x to the power 4/5, x to the power -1/5 is the lowest. I factor it out. Between x to the power x minus 4 to the power 2 and x minus 4 to the power 1, x minus 4 to the power 1 is the lowest. So what is remaining now? Out of the first term, I factored everything but a 2 over here and an x minus 4 over there. And out of the second one, I factored the 2, I factored x minus 4, and I also factored 5 to the power -1. That means I have to divide this by 5 to the power -1, which gives me a 5. And then x to the power 4/5 was divided by x to the power -1/5. So I factor x to the power -1/5, so I have to divide it by this, which x to the power -1/5 comes to the top and multiplies there, and I get x. And then now at this point I have everything factored, so the factors are, let's bring the 5 to the power -1 and that one to the bottom, and I get 2 divided by 5/5 root of x times x minus 4 times this entire thing, which 2 distributes 2x minus 8 plus 5x is 7x minus 8. Now set this equal to 0 and find the factors. So finding the factors and find the zeros of the denominator, because zeros of the denominator gives you where the function doesn't exist. So all the critical numbers are x equal to 0, over here x equal to 4, and over here x equal to 8/7. Out of these x equal to 0 is not within the domain. Look at this. 0 is not within the domain. So this one, we don't count. It's a critical number, but we don't count it in this problem. X equal to 4 is included in here, and x equal to 8, 7 is included. So the next step that we do is we evaluated f of 4, which f of 4 is easy to do. If I plug it in here, I get 0. And the other thing that we want to evaluate is f of 8 over 7. That one we have to plug into our calculators. Now let's say we plug in 8 over 7 in here, and the answer is approximately 9 point. So I'm sorry, h at 8 over 7 gives me 9.08, and h at 4 we decided gives us 0 because you plug it in. And then what else is remaining? You have to check h at 1 and h at 5. And h at 1, if you plug it in, it will give you 9 times 1, which is 9. H at 5 will give you the number approximately. These are the approximate ones because you have to do the fifth root. And 3.62. Comparing all of these together, what I get is the smallest number is 0. And the highest number is 8 over 7. So 4 and 0 gives you the maximum. 8 over 7 and 9.08 gives you the absolute maximum point for this graph. Now let's look at this picture. Green is the function h of x equal to x to the power 4/5 times x minus 4 to the power 2. And this yellow rectangle signifies that we're staying within the domain 1 and 5. And if you look at this, there is this little red point up there that you wouldn't have caught if it wasn't for the calculus of stuff. You would have, it's just the difference between that red point and the point next to it is so small, but that gives you the absolute maximum, and the absolute minimum is achieved right down here at 0.4. And these 2 points are neither absolute max or absolute min. Now it's time for a last iClicker of this section. iClicker question 4 of 4.2. Find the absolute extreme of f of x equal to x to the power 3 minus 3x plus 4 on the interval 0 and 2. And so please pause and solve the problem, and then we get back to it. Again, if you're finding the absolute extreme of, the first thing that you want to do is to take the derivative to find the local critical values. And f prime of x here is 3x squared minus 3. If I factor this out, I get 3 times x squared minus 1. And the two values that comes out of this are, factoring it further, I get 3x minus 1 times x plus 1. The two critical numbers are 1 and negative 1. One of them is in this interval, and that would be 1. The other one is not, so we ignore that. So now at this point, I have to evaluate f of 1, I have to evaluate f of 0, I have to evaluate f of 2. If I plug in 1 in here, I get 1 minus 3 plus 4, which is 2. If I plug in 0 in here, I get 4. If I plug in 2 in here, I get 8 minus 6 plus 4, which is 8 minus 6 is 2 plus 4, 6. So I see that the maximum value is achieved at 2, minimum value achieved at 1. And let's go back in here. This tells me that the maximum value is, so point 1 and 2 is the minimum, Where does it say 0.1 and 2 is minimum, and 2 and 6 is the maximum, and D is the answer.